Right then, let's talk about something properly brilliant. It's a machine that looks like it flew straight out of a science fiction film. It's big, it's menacing, and for the longest time, it was one of the most secret things on the planet. I am, of course, talking about the Northrop Grumman B-2 Spirit Bomber. This isn't just an airplane, it's a statement, a colossal flying wing design that whispers through the sky, almost completely invisible to its enemies. When you see it, you can't help but stop and stare. It doesn't look like it should be able to fly at all, yet it soars with a spooky, silent grace that sends a shiver down your spine. It's a true icon of aviation, a masterpiece of engineering born from pure, unadulterated ambition. The whole point of the B-2, its very reason for being, is stealth. It was designed during the Cold War with one job in mind: to sneak past the most advanced air defenses in the world without anyone knowing it was there. Think of it as the ultimate ghost. While other planes relied on blistering speed or flying at mind-boggling altitudes, the B-2 chose a different path. It chose to be invisible. This machine was the answer to a very tricky question. How do you deliver a knockout punch when your opponent has their guard up? The answer was to build a plane that didn't cast a shadow on radar screens, a phantom that could glide through hostile skies completely undetected. Building such a thing wasn't easy, not by a long shot. It took some of the cleverest minds in the world, a budget that could make a rock star blush, and technologies that were decades ahead of their time. The project, codenamed Senior Ice, was wrapped in a thick blanket of secrecy. The engineers at Northrop had to basically reinvent the rulebook for building aircraft. They threw out conventional designs with tails and fuselages and went all in on the flying wing concept, a design that had been tried before but never perfected. The result was something the world had never seen, and for many years, wouldn't see. It was a gamble, a huge one, but it paid off spectacularly. So what makes this flying wedge so special? It's a combination of things, a symphony of clever ideas all working together. You have its bizarre shape, the special materials it's made from, its unique engines, and a whole suite of secret electronic gadgets that we probably still don't know everything about. It's a puzzle box of innovation. Each piece, from the curve of its wing to the paint on its surface, is designed to do one thing: make the B-2 disappear. This is not just a story about a plane, it's a story about human ingenuity pushed to its absolute limit, creating a machine that truly defies belief and redefines what's possible in the sky. Now, how does it pull off its magic trick? A huge part of the secret is its shape. Look at it. There are no straight lines, no sharp corners, no vertical tail fins like you see on almost every other plane. It's all smooth, flowing curves. This is deliberate. Radar works by bouncing radio waves off an object and listening for the echo. A normal plane with its flat sides and tail is like a perfect mirror for radar, reflecting those waves straight back to the receiver, shouting, "Here I am!" The B-2, however, does the complete opposite. Its shape is designed to be a terrible mirror. The curves are precisely angled to deflect incoming radar waves away from the source, scattering them in all directions like a stone skipping across a pond. The leading edge of the wing is a perfect example of this genius. It's shaped like a complex, continuous curve. When radar waves hit it, they don't bounce back. Instead, they are channeled along the wing and scattered harmlessly away. The same goes for the rear of the aircraft, which has a sawtooth-like pattern. This isn't just for looks, it's another clever trick to trap and dissipate radar energy. Every single surface, every intake, every panel line has been meticulously designed to minimize its radar signature. The designers basically had to think like a radio wave and create a shape that would make them get lost. It's an incredibly complex piece of airborne geometry. Think about it this way. The radar cross-section, which is how big a plane looks on radar, is the key. A huge jumbo jet has a massive radar cross-section. The B-2, despite being enormous with a wingspan of over 172 feet, is said to have a radar cross-section of a large bird, or even a bumblebee. It's an incredible feat of engineering origami. This is achieved by making sure there are no right angles anywhere on the airframe. Right angles are a radar operator's best friend because they create strong, clean reflections. The B-2 is a festival of obtuse and acute angles, all designed to make it a radar nightmare. Even the engines are hidden away to help with this. On most jets you can see the big round fan blades of the engines spinning at the front. Those blades are fantastic radar reflectors. On the B-2, the engines are buried deep inside the wing. The air intakes are S-shaped ducts on top of the wings, not below them. This serpentine path means that radar waves can't get a direct line of sight to the engine fans, preventing them from bouncing back. It's this obsessive attention to detail, this relentless focus on deflecting and absorbing energy that makes the B-2's shape one of the most effective stealth tools ever created. It's not just a plane, it's a flying sculpture designed to conquer physics. The shape is only half the story. The other half is what the B-2 is made of. You can't just build a plane like this out of ordinary aluminium. To make it truly invisible, you need a special skin, a sort of technological cloak. The B-2 is built primarily from advanced carbon graphite composite materials. These materials are not only incredibly strong and lightweight, which is great for any aircraft, but they also have a very special property. They absorb radar energy. So, any radar waves that aren't deflected by the plane's shape get soaked up by its skin, like a sponge soaking up water. This further reduces the plane's radar signature to almost nothing. On top of this composite structure is a top-secret coating, a special paint known as radar absorbent material, or RAM. This isn't your average tin of gloss from the hardware store. It's a highly sophisticated, multi-layered substance filled with tiny iron-based particles. When radar waves hit this paint, they cause the iron particles to vibrate and generate a tiny amount of heat. In essence, the paint converts the radar energy into heat, which then dissipates harmlessly into the air. So, the plane's skin is actively working to gobble up any radar signals that come its way. This is why B-2s need to be kept in special climate-controlled hangars, to protect this delicate and very expensive coating. This anti-radar skin has another job too. It has to manage the heat signature of the aircraft. Smart missiles don't just hunt for radar reflections, they also look for heat. The B-2's engines, weapons bay, and electronics all generate heat, which could make it glow like a Christmas light on an infrared camera. The skin and the internal systems are designed to manage this thermal signature. The exhaust gases from the engines are mixed with cool air and vented over the top of the wings through special slot-like exhausts. This cools the plume and masks it from heat-seeking sensors on the ground, making the B-2 a ghost in the infrared spectrum as well. The manufacturing process for these materials is, as you can imagine, incredibly precise. The composite panels have to be cured in giant ovens called autoclaves under immense pressure and heat. The tolerances are minuscule. A single flaw, a tiny gap, or an imperfectly applied layer of RAM could create a hotspot that reflects radar and compromises the entire mission. The maintenance is a Herculean task. Every scratch or chip in the surface has to be painstakingly repaired with what is essentially high-tech putty and paint to maintain its stealth characteristics. This amazing skin is both the B-2's greatest strength and its most demanding feature. Now, a stealth bomber is no good if it can't get to its target. The B-2 is powered by 4 General Electric F-118 GE100 engines, but as we've discussed, you won't see them dangling from the wings. They are buried deep within the aircraft's structure. These are non-afterburning turbofan engines, which means they don't have that thunderous afterburner roar you get from a fighter jet. This is by design. An afterburner creates a massive plume of fire and heat, which would make the B-2 light up like a firework to enemy sensors. Instead, the B-2 flies at high subsonic speeds, just below the sound barrier, relying on stealth, not speed, to survive. Its flying wing design also makes it incredibly efficient, giving it a staggering range of over 6,000 nautical miles on a single tank of fuel. Flying the B-2 is unlike flying any other aircraft. Because it has no tail or rudder to provide stability, it's inherently unstable. A human pilot simply couldn't keep it level on their own. The plane is flown by a sophisticated quadruple-redundant fly-by-wire system. The pilot's inputs go to a computer, which then makes thousands of tiny adjustments per second to the control surfaces along the trailing edge of the wing, called elevons, to keep the plane flying smoothly. The computer is constantly working to prevent the aircraft from tumbling out of the sky. It's a technological tightrope walk, and the computer is the ultimate balancing pole, making this radical design possible. One of the B-2's most remarkable feats was its first combat mission during Operation Allied Force in 1999. B-2s took off from their home base in Missouri, flew a non-stop 30-hour round trip to Serbia, dropped their precision-guided bombs, and flew all the way back without ever landing. This demonstrated the B-2's incredible global reach and its ability to strike anywhere on Earth from the safety of its home base. The crews, consisting of just 2 pilots, had to endure marathon missions, taking turns to sleep and operate the aircraft. These missions proved that the decades of development and astronomical cost had produced a weapon of unparalleled capability. In the end, the B-2 Spirit is more than just a collection of advanced parts. It's a symbol of what happens when you dare to dream big. It pushed the boundaries of aerodynamics, materials science, and computer engineering. While only 21 were ever built, its legacy is enormous. It is a silent guardian, a technological marvel that still looks futuristic decades after it first flew. It proved that the most effective way to win a fight is to ensure your opponent never even knows you're there. And that, in the world of high-stakes aviation, is the ultimate checkmate. Hammond out.